Hi everyone. This is a short video on the use of LTspice for our labs. So if you've never used a circuit simulator before, this might be fairly new to you. If you have used a circuit simulator, this might be just a review. As I asked you before on my email, if you want, you can install LTspice on your computers. It's completely free. Just see my email regarding that. But LTspice is also installed on all of our lab computers in the ECE lab, EC115 lab. So if you go to the lab, it should already be installed and you really don't have to bring your laptop. But outside the lab, you might want to have it once you learn how to use it. It will be very useful for your course and other courses outside EC115. So if LTspice is installed on your machine, including the ones in the lab, to start it, simply go to the LTspice icon over here and double click. So when you double click, you will see this background image. However, if this is the first time you're launching LTspice, you might have some startup options that have to be executed for about a minute or two. That's perfectly all right. Just wait, and when it's completed, you should still see this picture with this background. So to enter in a schematic or to start a new schematic, we simply go to this icon on the top here, which says New Schematic. Click on it, and you'll see this gray background, and we have a clean schematic, and this is where we'll enter our components. Now, to start with, we will not be using too many components. We will only be using voltage sources, current sources, a resistor, right, or two or three or four, maybe 4 or 5 resistors, and the ground symbol. So that's the extent of the components that we will use. Although when you look into the library of components that's available with this tool, you may find that there are a whole lot of things, but don't be intimidated by that because we're going to be only using a small portion of that. Okay, so let's start to put some components in, typical of the components that we see in the course. So let's enter in maybe a voltage source, a current source, and maybe some resistors. Let's just start with that. So let's say we want to enter a voltage source. So the components are located in this, it can be accessed through this icon called component on the menu bar. So when you click on that, you'll see a bunch of items for all the components that are in LTspice. There are even some directories which contain hundreds, even thousands of components. But for us, let's start with the basic voltage source. If you keep going to the right here, there's an item called voltage. Well, shows it to you. It shows you a little preview. If you click OK, you will see that now you have this voltage source on your desktop. So and it will snap in the places that are given by those little dots. So those are the snap positions. Once you're satisfied with roughly where you want to put the voltage source, right? Simply click your left mouse button down, and there it is. As you move your left mouse button away, or when you take your mouse button away, you see that there's another copy of the voltage source in case you want to put another voltage source on your schematic. So if you do, you can keep placing these voltage sources in your schematic, as many as you want. Here we only want to place one voltage source. So we're basically done with placing sources. So at this point, you could either hit the escape button on your keyboard, or you could click the right mouse button, and that will exit out of this component entry mode. So it's quite simple. Now we have a voltage source placed on our schematic. Now there's two things to notice with these sources. In fact, all elements in LTspice generically. First thing is that LTspice will number your elements. So that's called the specification. Sorry, that's called the index, right? So like V1, V2, V3, V4. Sometimes it's called a reference designator. So LTspice automatically does this. So it has called this voltage source V1. If I place another one, I'll call it V2, so on and so forth. You don't have to modify that V1. You can leave it as it is, or if you want to change it to, for example, VS1, you could do that. So let's just call this source name VS1. Take your button and simply go over that element, and click the left mouse button. If you click the left mouse button, you'll be able to change this. Now, another thing with LTspice is that as you move your mouse button to several different locations on the diagram, And if you look on the lower left-hand corner of the window, down here, it's empty right now, but if you look down here, it says right-click to edit the name of V1. So it already tells you kind of what to do. I'm kind of telling you verbally as well, but if you forget and you hover over the element, it'll tell you what to do. So if I right-click there, and I can just type in, for example, VS1, and that'll be the new name of my source. I just OK it, and now that's called VS1. Now, this V down here is where you enter the value of the voltage. So 5 volts, 15 volts, etc. And if I hover over that, you see it says right-click to edit V, the value of VS1. So if you right-click there, and maybe you type in, for example, 10. You can also enter in 10V, but just for the values, we won't use the units for now. So 10 is fine. You OK it. Now you just place your first element, and you've actually changed the label for it, VS1, the reference designator. In addition, you change the value of the voltage source to 10 volts. Okay. Now let's say you wanted to change this voltage to something else. You right-click on it, and you say, for example, 15 volts. OK it. And now it's 15 volts, right? So it's quite easy once you get used to it. And pretty much every component, including resistors, current sources, work this way. Every element has a reference designator. For example, for resistors, R1, R2, R3, R4, right, etc. And then their values, right? So you enter in the values for those resistors. Okay, so let's enter maybe a resistor. Okay, so we can do the resistor entry 3 different ways. Okay, first we can go back to the component and search for the element called RES. That's a resistor. There's also RES2. It just has more of these wiggles. I just prefer RES. So you could enter a resistor this way. Okay, so let's do that first. Okay, so you OK it and you say, okay, where do I want to enter this? Well, I want to have it horizontal, not vertical like this. How do I rotate? Well, you can use Control R. Hitting the Control key and then hitting R together, Control R, right? Hitting Control and hitting R will rotate this element. You can also move your mouse button to this top region here where it says rotate and click on that, and you can also get a rotation, right? So now this resistor can be placed anywhere, and as I move my mouse, the whole schematic moves up and down. I know it's kind of weird, but you can easily place this anywhere you like. For example, right here, left click, and you've already placed resistor R1. Now, when I move my mouse away, there's already an R2 that I can also put down. Now, maybe I want to put my R down vertically. So here, maybe I use Control R, okay, and I've done that. Or I can use, for example, rotate until you see the right thing, and then move the mouse below, just kind of like move it around. You might have to, try out this little bit, and you get used to it, and place it maybe right here. You can always move things later. It's not a big deal. R3, where should I put R3? Well, I want a horizontal over here, right? Put it over here. Maybe I put it maybe right there. And R4, I want it kind of above. Maybe I want to put it right up there or something. Okay. All right. And then I'm done. I don't want any more resistors. I right click or escape, and now I'm in the normal mode here where I'm ready to place more components. At this point, maybe you want to do extent zoom. So zoom to full extents. If you click this, so you'll get a much bigger picture. And also, if you have a wheel on your mouse, if you wheel back and forth, you can kind of do maximize, minimize this way as you put more and more components. So those are good to know. You can also do zoom out and zoom in or something like that. Where you zoom negative and zoom positive, where you can select with your left mouse button a window. I mean, I'm sure you've done this with other tools, but it's all there, and you don't have to really use them if you don't want to. But right now we have our 4 components, 4 resistors and a voltage source. Maybe I want a current source. Let's get a current source. So I go to, and I want to put the current source way on the right. So maybe I zoom out a little bit like that, and then I go to the components. I click on it, and I say, okay, where's the current source? Believe it or not, it's called current. There it is. Do I want to point up or down? Well, I can choose that. I just select it, but I'm okay with it being face down like this. So I put it somewhere, maybe over here. Again, it all depends on what you want. And then one other thing that you need in a circuit is going to be the ground symbol. So circuit simulators are pretty much based on a modified version of nodal analysis. That's what they use actually to do analysis. And we've seen nodal analysis a little bit, but like I said, simulators use that too. They use a modified version of it to do all these calculations. Anyway, we have our components. We have to wire them up first. So before we put the ground symbol, we'll actually wire them up. I want this to be a little further apart. I want to put these things in different locations. How do I move things around? Like, how do I move this element VS1 further to the right? And maybe I want this I want to be IS1. So I might want to do several like small changes. I can do them now or later, right? We know what to do. For example, this current source, I haven't really put a value on it. Let's put all the values first. Like for example, this I1, I want to call it IS1. If I put the cross over it, you see the cross changes to like an insert symbol. And if you read the lower left-hand corner of the screen, right, it says right-click to name the emitter of I1. So right-click there, and I'm going to call that IS1. I can call it anything I want, as long as it begins with an I, because the beginning word is very important, okay? And the value, I don't know, make it 5 amps. So put 5 there, and I'm done with that, okay? Now my resistors are okay, except that, as you notice, I have the index R1, R2, R3, R4. Those are the names, but the values have not been specified. They're sitting at R. So those are just placeholders. You have to put values in there to run a simulation. If you don't, you'll probably get an error saying you haven't specified the value for that resistor. So it'll ask you to enter that in. If you see that, don't worry, it's not really a fatal error or anything like that. It means that you haven't really completely specified the circuit. So let's enter in some typical values. R1, again, I go on the R here. I'll put in 1, R2, 2 ohms, R3, 3 ohms, R4, 4 ohms. And I have all my component values now, and I have to just wire it up. But before that, I want to spread these apart a little bit just for my purposes. So what I can do is, before I can spread things apart, I have to select this component. So how do I select this component? Well, one way to select it is use the drag or the move button. So if I go and click the move button, click on that, you see the icon changes into a hand, and I can left click and I can move the voltage source anywhere I want, right? And then when I'm done with what I want, I left click to location, and now I'm done with moving VS1. I can select R1 and put R1 to a new location, right? And then maybe move R2 to a new location, and maybe R4, right? So this just depends on how you want the circuit to look like. It's up to you. Circuits can be connected as you like, but depending on how long you make the wires, they may kind of look slightly different than your classmates. But as long as the connections are the same, the circuit works the same way. So maybe I like this a little better. Okay, let's wire things up. So I'm done with the moving, and you see this hand here. So if I right click, I get out of the move mode. Okay, so I want the wiring mode now, and to wire, you go up to this pencil. Okay, it says wire. Click on that, and you get this crosshairs. And all you gotta do is really go through these small squares on the components. So I can start anywhere. Maybe I start down here below the voltage source. I click, and I can literally go through the components and wire these things up. So I'm left clicking as I want to make a turn basically, and when I left click here, I'm pretty much done. And when I hit the right mouse button, it kind of clears off all those wires that were going through the resistors. It kind of cleans it up. So I want to connect R2 as well. Maybe I want to connect R2 this way. So all I did is click the wiring button, okay, and then go from this bottom to the top, and then right click to get out of that mode. That's connected now. And I want R4 to be connected sort of across. So a wiring button again, and then maybe I go, somewhere over, maybe I'll start over here. Okay, so let me zoom out to show you what I'm doing. So I'll start over here, go on top, and then go through the component, top of the current source, right click, and I'm pretty much done. Zoom out, and you can see the whole circuit now. It's pretty clean. Now, of course, if I want to, I can make some modifications. For example, move, right? you can still move components, but if you simply use this move button, what happens is if I select R1, it'll just move that component, right? If I just move that component. But I wanted to stretch the wires, okay? So how do I undo the move? Just right click, and it's as if you haven't even moved it. There's another button here called drag, okay? If you use the drag button, then these wires stretch. So the wires stretch as you move, and you can kind of fine tune how these circuits look like. Maybe move this around a little bit, maybe move that around a little bit. I mean, I guess it depends on how much, how fine you want it, basically. But now, as it stands, we're pretty much wired the circuit, except that, as I said, the circuit simulation runs based on nodal analysis, and we know that nodal analysis requires a ground symbol. So we have to declare one of the nodes to be the 0-volt node or the reference node. And so here is the voltage ground symbol. So we simply pick that, and you can place it anywhere you like. Maybe you place it somewhere down here, and then wire it to the top like this. And now we pretty much have a complete circuit. It's ready to be analyzed. Okay. So I hope so far you've been able to follow me. If you like, you can go back and review what I've done, and go back and replay it basically slowly, and you'll be able to see it. So I was saying to you that there are many ways of entering the, like for example, a resistor. One way was, you go here and you pick RES. Here is resistor RES, and if I OK it, it's right here. I can place another resistor, and you notice it's called R5 now because I have 1, 2, 3, 4 already in the circuit, so it starts with the next number. Okay, so if you want to get out of this mode, if you simply do escape, okay, so I undid that, and I'm not entering it that way. So one way is go to the at least for a resistor, you go to the component list, you select RES, you place it, you do Control R, or you do the rotation, right? The rotation to rotate. By the way, if you look now, you see the rotation is not active, right? Unless you have a component that you're placing, that rotation symbol won't be active. It's all grayed out right now. So that's one way of entering a resistor. Another way is you go to the menu item here, resistor. If you click on that, here you have R5 again, right? You can enter a resistor this way, and then use your Control R, for example, Control R, Control R, Control R, and you can place a resistor this way. Okay, again, right click or escape to get out of that mode. Okay, another way you can enter it, it turns out that there's actually a keyboard shortcut. So if I just type the letter R, that's another way you can enter a resistor. So there's 3 ways. Choose one. Choose one, but after a while, you might find yourself just using the R on the keyboard because it really is quicker. Okay. Okay. So that's just some side notes, right? Okay. So now we're ready to simulate, but let's take a look at some of the things that are in other words, let's look at some of the details that LTspice kind of gives you. So first of all, you know that LTspice labeled the components like R1, R2, R3, R4. We already saw it. We've seen it. And we know that we can change those things. So if I don't want R1, I can change it to RX1 or R15 or R150. I can easily change that. It's not a big deal. The next thing we know is that they have the values. So these values have to be entered. If you just leave in the default, your simulation won't run. So we noticed that. But what we haven't seen is that behind the scenes, the simulator LTspice has already made a listing of all the components in the circuit and their connectivity. So it's actually, first of all, it actually numbered all the nodes. Okay, numbered all the nodes. How many nodes do we have in the circuit? Well, we have the bottom node, right? With this bottom node over here, which we call the reference node, and then one here, and one here. So we have 4 total nodes. One is called 0, and the other 3 are the unknown node voltages. Maybe we call them V1, V2, V3. Maybe, right? We can call them anything we want, but that's what we would typically do if we're doing this by hand. Now, the thing is, LTspice has already labeled those, but it's behind the scenes. Now, what are those node voltages called? Very easy to figure out. Just take your cursor, it's a cross, right? And if I go on that bottom node there, it says this is ground, right? Lower left-hand corner, information place there. There's an information location where you get information from LTspice, right? So if I go to this top one, it says this is node N001. So that's called node 1, right? But it's like, it says 001. So you could go to, very, very high number of nodes. In fact, you could have probably 1,000,000 nodes if you really wanted to. So this is N001. You go here, it's called N003. Okay, and then this one is called N002, right? I didn't pick those. It automatically picked those things while it was putting together the circuit and while we were connecting things up. It actually doesn't matter what those nodes are called. It makes no difference as to the values that we'll get when we simulate the circuit. But it does matter when you look at what's called the netlist. And the netlist lists all of the networks, basically, all the network elements, in other words, the components, line by line, and it tells you exactly where they're connected between. Okay, so let's take a look at that because we'll see it later how it can be useful. If you go to the menu item View, Spice Netlist, and click on it, you'll see this little window popping up, and it's got a bunch of text information. In fact, this is what actually LTspice uses to simulate the circuit. So first of all, this first line here, it's a comment. Anything that has an asterisk in the first element is not read in, so it's a comment line. And you could, for now, neglect the bottom two lines. The most important information here is contained in these lines here that I'm highlighting. So if each line represents a component, if the line begins with a V, it's a voltage source. If the line begins with an R, it's a resistor. If the line begins with an I, it's a current source, right? And you can see those node numbers being used there. Like for example, if we look at this carefully, it says VS1, right? That's our voltage source that's sitting right here. It's between node N001 and 0, which is your ground node. So here's N001 and here's ground, and the value is 15, right? So it's the label of the component, and the first letter matters. It's a voltage source. It's between N001, which is the positive terminal. The first terminal that's always written is the positive, and the second is the negative, okay? And then this is the value of the voltage source. Let's look at the current source, okay? Current source is the last line. It says IS1, it's a current source, I, right, current source. It's pointing from N002 to 0, and its value is 5 amps. And here it is. This node here is N002, then this is the node 0, right? Those are the first two numbers, and that's 5 amps, right? So it's very, very straightforward. Now for resistors, again, resistors, it doesn't matter which way you connect them, right? So it's because we don't know if the current is going to flow left to right to left. We don't know. We don't know that. For the voltage sources, it's important to know if the current is flowing from top to bottom or bottom to top because that sets the current. But for resistors, the currents and voltages are calculated. So where we say VR1, IR1, right? That's what we choose based on Ohm's law and our arbitrary direction initially, right? I mean, they have to line up with passive sign convention. But if VR1 is from left to right or right to left, we don't know if our number is going to be positive. If you go back to some of the homework you did, you will see this. So if you look at, for example, R1, here's R1, and we know that from what we noticed before, that R1 it says it's between N003 and N001. So it has taken this right node first and the left node second, right? So just again, concentrate on this. It says it's between node 3 and node 1, and it has a value of 1 ohm. That's R1. So it's saying that this is N003. Look at the lower left, okay? And this is N001. Those are the nodes. So it has chosen this node first and this node second, okay? So just know that that's how it appears when we look at the Spice netlist, right? Would it matter if it was the other way? Not to the overall simulation of the circuit, but some of the details may look a little different. In fact, there might be a sign difference, but I'll tell you exactly what that is when we come to it. But just note that the netlist tells you exactly how everything is connected, and this is what's actually simulated. Every simulator simulates this text input. In fact, this is kind of like your program that you're compiling and simulating. This is what it is. Okay. Now, most of the time, nobody looks at this, but I'm just showing it to you because if you understand this, you will really understand simulation very, very well. And not only that, you'll be able to figure out intricacies, details, and even some mistakes that you may make later on. Why is that happening? You look at the schematic, the net list, and you'll be able to tell right away. Okay, great. So anyway, this what I just show you, you don't need that because in fact we are actually ready to simulate. We were ready to simulate maybe 5 minutes ago already, but this is ready to simulate now. The only thing it's missing is the type of simulation. Okay, so there's different kind of simulations we can do. Now, for us, we're going to do what's called DC analysis, or what's also called operating point analysis. What is that? This is where we calculate all constant or DC voltages and currents for all the elements. It's basically what we've done on the homework. That's called DC analysis, or sometimes it's called operating point analysis. There are other analyses we can run where we can apply, instead of constant inputs like 15 volts and 5 amps, we can apply sine waves or other kind of waveforms and run that simulation. Those are called transient analysis or time analysis. We can also run frequency analysis, but we're not there yet. But when you enter the simulation command, you're telling the simulator what to do with what you've just entered in. And the way we do that is a couple of ways, but the simplest way is if you simply hit this, click on this running man. It says run here. So because we have not entered in a type of simulation, it will ask us. Okay, so click the running man, and then you will see it says transient, AC analysis, DC sweep, noise, DC transfer. We're interested in this last one, the one to the far right, DC operating point. Simply click on that, and LTspice will enter this command on the schematic. Once I hit OK, and it will simulate it as well. So click on it, and the simulation is run, and my values are actually calculated here, and they're shown in this tabular format. But there are other ways to show this information, but our simulation is basically done. Let's close it. Okay, let's close it, and then we can actually display all of the values. Okay, now just to remind us what nodes these are, we can actually enter the node names as well. So that's what I'm going to do now. I mean, I showed you already that if you say view spice netlist, you get this net list of connectivity information and node names and values. Very useful. Now, if I want to, I can name these nodes anything I want. Pretty much anything I want. Typically, we call them N1, N2, N3, N4, just so that we're consistent. So let's just do that. So instead of 001, I'm going to update those. So what you do is, if you want to rename a node, take your cursor, and then you say, if you look at the bottom, it says N001. So if you right click on this and say label net, okay, if you say label net, it's got this empty box with some question marks. So let's just say N1 there. So if you type in N1 there and click OK, you can just take that little label and go anywhere on this line. Maybe you want to go over here, okay, and then just click, and now you have entered a node name N1 for that node, and you see that there's a copy of it here. I don't want it to be copied anywhere else. So if you right click, you get out of that, and now I've called this node N1. I want to call this node N2. So let me do the same thing here. Right click here, label net, N2, okay, and now this node is called N2. I can put it here, I can put it there, I can put it down here, I can put it right on top of this if I want to. So I click right on top there, and now that's called N2. And we have one other node, which is right here. Again, right click here, label net, N3. Okay. And now I can maybe put it somewhere here, right click, I'm done. Okay, I'm done. And to see what happened here, I can just say view spice netlist again, and you see all the node names have changed to what I put in. Right? Like for example, R1, right here, is between node N2 and N1 and has a value of 1 ohm. Okay, and so on and so forth. You can just double check this. Okay, so we've changed something. Let's run the analysis again. Okay, how do I run the analysis? Well, if you notice down here, it says OP. So this is actually the analysis command. I don't have to re-enter each time. It's already entered in. So all I got to do is rerun it. Simply click here, run, and here's the values again. And the thing is, LTspice makes it very easy to display these node voltages because the only unknown here is the node voltages. Okay? Because if you know the node voltages, you'll be able to figure out every voltage difference across any element. Okay? Very, very easy. The way you get the node voltage is, after you run the analysis, okay, so we run the analysis, you take your cursor, you go to that node, and once you hover over it, it'll already tell you what that voltage is actually. If you notice down there, it says VN1 is 15 volts. Voltage of node 1 is 15 volts. Of course, it's a node voltage, it's with respect to ground. So it's saying this is 15 volts, assuming down here is 0 volts, practically speaking. Okay, so plus minus 15. Let's hover over N2. That voltage is 8.695, etc. volts. This node voltage, okay, 2.82, etc. Now, this whole thing up here is N3. So even if I go over here, you see that it says VN3 is 2.82, etc., right? So I can actually display those on the diagram. If I go on that node, and if I read down there, it says DC operating point is something. If you simply left click on that node, okay, you get the value of the voltage, right? Here's the node for N2. Here's N2, okay? If I click on it, you will see momentarily you get this little probe symbol, okay? So if you left click and leave that, keep left clicking the node, you'll see that probe right there. You don't have to keep it there, but move it around a little bit. Just take the left mouse button out, release it, and you get this voltage. So simply clicking and releasing will get you these values. And now you see, this V is kind of going over this N3. And maybe I want to do some movement here. Maybe I will take my drag, and I will take this resistor and drag it down a little bit. I can take this calculation, sort of drag it down a little bit to make it look good, right? But this is it. Now you have all the voltages, and you know exactly what's going on here. For example, if you want to know the voltage across R1, you can see that the resistor 1 has 15 volts on the left side and 8.69 volts on the right side, which means the left side is higher potential and low the right side. So that means there's going to be a voltage drop of 15 minus 8.695 volts. Okay, so you can simply calculate it or just realize that it's just some kind of a positive number, right? So what is it? It's roughly 15 minus about 8.7, right? So if you subtract that, you get 6.3 volts. So that means the voltage from left to right is 6.3. What's the current going from left to right? It's 6.3 volt drop divided by 1 ohm. So there's 6.3 amps going from left to right. That Ohm's law tells you that. You can do that with every resistor here, right? Every single resistor you can do, right? If you think about it, this resistor R2 has about 8.7 volts on top, 0 on the bottom, so the voltage drop is plus minus 8.7 volts, right? So there's 8.7 volts approximately across R2. So if you take 8.7 volts, right, and you divide it by 2 ohms, and you get about 4.35 amps. That's going down from this point down this way. Okay, so on and so forth. You can do this with all the resistors. Now, another way you can get the current information is if you hover the again, remember, for R1, we said there was about 6.3 amps going from left to right. So if you take your cursor and hover it right over R1, where it turns into this index finger, and if you read the bottom left corner, you will see some information, right? So it says, DC operating point, IR1, the current through R1 is negative 6.3 volts. Well, how come? Isn't it 6.3 volts? Right? That's a question right there. And the answer is, both answers are true because our 6.3 is true. We calculate the current going from left to right. LTspice, by definition, when you say I over the parentheses R1, it calculates the current from its first node to the second node in the netlist. So let's take a look at the netlist. View, Spice netlist. Look at R1. R1 is placed between N2 and N1. So this node comes first, this node comes second. So when LTspice reports IR1, it's giving the current from N2 to N1. So it's giving you the current from here to here. And that's why that current is negative. So we're both talking about the same thing, but we're measuring it differently. And that's why I kept on saying in class that it really depends on the way you measure it, because once you build a circuit and run it, there's only, the voltages and currents that are present in the circuit. So if you measure it the opposite way of the way they are, right, you will get a negative. But it doesn't change what the circuit actually does. So we can try with other elements. For example, R2, we know that there was about 4.35 amps going down through R2. And if you click on it, or if you hover over it, you see it says 4.35. Well, that's true, right? That's exactly what we said. But let's take a look at the netlist. So if you say view Spice netlist, so for R2, you see that N2 comes first, right? So N2 comes first and then 0. So when you say I R2, I parentheses R2, LTspice means the current going from N2 to 0. And in fact, that's exactly what we had calculated, right? So you can do this with every element, right? I mean, again, just looking at this 3 ohm resistor, you see the left side is about 8.7, right side is about 2.8. So I expect positive current going from left to right. It's going to be 8.7 minus 2.8 over 3, right? So, I mean, roughly speaking, I'm not calculating these to the very last digits, but if you do, like, for example, 8.3 on the left of R3, and then if you do 2.82 on the right side of R3, the difference is 5.48. So there's a drop of 5.48 volts as you go from left to right. So this side is higher than that side. So the current flows downhill. So we take 5.48 divided by 3. That tells me I should have 1.82 or 1.83, something like that. 1.83 amps going from left to right. So what does LTspice tell me? Hover over the component. It says it's minus 1.95, right? Now, why is it telling me that? It's because it must have this N3 first, then that N2. So it must have this node first, then that node on the Spice netlist. And it'll always report the current going from N3 to N2 for this one, right? Unless, of course, I flip it. I can flip the component and, I can change the N2 and N3 if I flip the component on my schematic, okay? But now I'm getting into too much detail. All I'm telling you to do is, if you examine the netlist, you will get this information. And just remember, if you say I R1 or I R2, I R3, right? In LTspice, if you see something like that, it's giving you the current going from the first listed node to the second listed node in this netlist. Okay? Or just realize that practically speaking, of course, if this side is higher than that side, positive current is going to go from left to right. I mean, that's obvious, right? That's obvious. But I just don't want to be confused. I don't want you to be confused with if you see something else on your information. Now, you might have noticed that as I go over the components, I also get power dissipation, right? And that's true for every component. Like if I want to know power dissipation or power absorbed, right? We call it power absorbed also. Over R1, you see it's like 39.7 watts. R2, about 37.8. R3, about 11.48. R4, 37.05. How about the sources? Same thing, right? We get the power absorbed by the sources. You see that the current source is absorbing 14.3 watts, 14.13 watts, which means it's, energy is stored in there, right? It's not generating power, it's absorbing and storing the power. It's being charged. Whereas, all these R1 through R4 and this current source are absorbing power. So this is absorbing and storing. The resistors are absorbing and dissipating it as heat. Now, this voltage source, if you look at the dissipation, it says minus 140 watts, which means minus 140 watts, absorbed, which also means plus 140 watts generated. So you can do that power absorbed calculation, where some of the power absorbed must be equal to 0, and for the voltage source, you'll have a negative value. The rest of the components are going to be positive. Hopefully, when you add them up algebraically, they add up to 0. Okay? So I hope this information is useful as we go along. Like I said, you might have to pause the video and go back a little bit and listen to what I say. And I hope I'm not saying something that's inconsistent, but you see that it's fairly easy to set up. I'm giving you much background information that you may not really need to use, right? But this is kind of how you set it up. And of course, once you set it up, you can easily change components and rerun the simulation. That's the beauty of it, right? So let's say I don't want this 15 volt source. I want, I want this to be a 30 volt source, or maybe I want this to be an 18 volt source. What's going to happen? Right click on this, right? Right click on 15, and then go here, change it to 18. Okay, then you OK it. Now the component value change, but these values haven't changed yet because I have not rerun the simulation. Okay, I have to rerun the simulation. Hit the running man. Okay, and the values pop up. Close it. And then so now these are the new values. Of course, this changed to 18, obviously, and then these values also changed. Okay. You can do the same thing with a resistor value. Oh, I don't want 1 ohm here, I want 10 ohm. Right click on the 1 ohm, change it to a 10 ohm, right? OK it, and then I have to rerun the simulation. Rerun the simulation, okay? And then you get these values. And you see over here you get millivolts, which means 10 to the minus 3 volts. So you have something like 307 millivolts, which is same as 0.307 volts approximately in this case. And then of course we can go back to where we were, and there's a very nice way of doing that, and that's called undo. And here's the undo symbol. So if you undo, I just went back from R1 went back from 10 ohm to 1 ohm, and if I do undo again, VS1 went back from 18 to 15, and now I can rerun my original simulation and again view the new voltages, right? And then I can view the new currents, etc. Okay, so the only thing to watch out for is that voltages are clear, the participation is clear, and the current, right? Don't just look at the value there and says, oh, it's minus 6.3. The question you should ask is it left to right, right to left? We know by just looking at it that positive, right, positive 6.3 amps is going from left to right because the left side is higher than the right side in voltage. And the reason that's being reported negative again is because in the netlist, this node appears first, and therefore IR1 is actually pointing from right to left. Exact opposite of what we just measured by just looking at it. I hope this is helpful. I hope you will use this software, and I hope this week in the lab that you will have a enjoyable time doing these simulations, because this is very convenient to get these values computed in a very, very short time, and entering in the components. Initially it might be a little bit different because you haven't used the software, but once you start using it once, twice, then you'll be an expert in it very, very quickly. Very, very quickly. It doesn't take too much. And I just highlighted all the things to watch out for as you're putting these components on the schematic. How you enter them, where you enter the values, etc., etc. So I hope you will try it. I hope you will enjoy it. And I hope you can even use it for checking your work for different kind of circuits that we will experience, we will see in EC 115. So thanks very much for now. This will be posted to YouTube. Like I said, if there are any comments, please email them to me. Other than that, have a good rest of your weekend. There's about a few hours left. And I hope next week's experiments are enjoyable. And thank you very much. Have a good night. Hope to see you next time. Bye-bye.